Welcome to DevOps Summit Canada 2021. I want to thank the organizers of this event for inviting me. I do appreciate it. So what we're going to do to talk about today is wrapping your head around GitOps. GitOps is a new way of really pushing continuous deployments. I think it has a lot of potential. And if you're looking into moving into a GitOps model or you want to know more about it, you are at the right session. And thank you so much for attending my session. I know there's many options in these conferences, so thank you for choosing mine. So what is GitOps? Is it a new continuous delivery engine? Does it compete with things like Jenkins? Is it GitHub Actions? Is it infrastructure as code, or is it operations by pull request? We really need to dive in and understand what GitOps is, because if you assume it's going to do something that it's not, you're going to be very disappointed. And today we're going to try to make sure that doesn't happen. So first, meet me. I am Tracy Reagan. I am a microservice evangelist. I'm really, really excited about the microservice technology. I'm super passionate about configuration management. I am the CEO and co-founder of a company called DeployHub. We have a microservice catalog that's new to the market, sort of an emerging market that we will talk about a bit. I am the community director for the Ortelius open source project. TechBeacon has listed me as one of the top 100 DevOps visionaries. I am a founding board member of the CD Foundation. I'm honored to be on that board. And I also am part of the DevOps Institute, I'm an ambassador for them. And I have about 20 years of experience of doing this. So if you ever have questions about this, I'm always happy to chat. You can reach me on LinkedIn. I'm at Tracy-Reagan-OMS. So reach out. I'll send you an invite, a calendar request, so you can put some time on my calendar, and we can chat about this at length. So D, operations by pull request is the correct answer to the multiple choice question I asked earlier. So GitOps is the process of managing all deployments using what's called a state-based process. It's declarative. It's a declarative method, meaning that it is not something that you sit down and you script with logic, or you sit at a console and type things in and do it in a more imperative way. GitOps employs a version repository. It doesn't matter which one. You can use any version repository. I think the term Git became popular because so many people use Git or GitHub, and that just became the kind of the new name for clinics, right? So GitOps can use any kind of version repository, and it uses that to centralize the scripts that you're going to use to move across your dev, test, and prod environments. And if you really want to understand GitOps, we have to really understand infrastructure as code, because it is really the precursor to GitOps. And infrastructure as code focused on spinning up new environments and how we can do that more efficiently. So what is infrastructure as code? The provisioning, management, and configuration of data centers using declarative definition files. It's a shift away from manual updates. I'm sure all of you have had the experience. We've got somebody on the operations team that if you want something done, you call them and they start typing away on their keyboard and they get it fixed for you or updated. That's imperative. Or something that's more interactive. Infrastructure as code saw that was a problem because it couldn't be repeated easily, and looked to how to fix it. And creating a declarative method where you define the state of what you're trying to achieve, and then something else does all of that logic, was a better way to move forward. So understanding the difference between imperative and declarative is important for understanding infrastructure as code, or GitOps. So historically, as we all know too painfully well, operation teams have always relied on these imperative approaches to managing the data center. There's always somebody who is usually the go-to person that everybody calls on to get things done. That is baked in an imperative method. And then sometimes that individual, because they knew this process so well, would write a script. And that script would then sort of create the same experience that he had sitting at his keyboard typing commands in at the command line. And if the script was done well, it used if then else logic because it needed to, because you'd have different situations come up that you would have to add to that script. Just intelligence, the same intelligence that the person was using to update things at the command line. So when you think imperative, think one-off scripts, think of things being done at the command line, pushed forward or put in a script that is executed on a particular, in a particular environment. So declarative takes a totally different approach. It's a model-based approach, and you define the desired state as opposed to writing something imperative to get to that desired state. It executes what needs to happen to achieve this desired state, and it works well for managing or adapting to what we often call drift. So let's say you want two environments set up and somebody sits down and imperatively types in all of this to set it up, and then they go do it again. What if they change just one parameter? Maybe they didn't realize it, but they did. Now we have drift between these two environments. In a declarative model, you don't have that problem because you define the desired state in a deployment file or in a script, and what they call an operator does the work. So the operator is what's doing the heavy lifting and is managing all the logic to get you there. So as I said, infrastructure as code has an operator, and that operator lives outside of the environment because it's going to spin that environment up and it's going to bring it down. So what we call day one and day in activities. Now you also have day two activities, and day two activities may mean we're going to tweak an environment, maybe change a parameter so it has, maybe there's some degradation or that we need to improve the performance, so we're going to change a parameter. We would do that in IAC through updating a script, pushing that out to the operator, and the operator would do the work. But when you talk about day two events, you're talking about doing a lot more work. Now, this model that you see here with an operator that has the logic, and you have a desired state that you check in the declarative definition files, and it goes and it creates your cluster, is going to look very much like GitOps. But GitOps is about scaling the day two events. Day two events is everything that you probably do. If you're not an operations person, if you're an application team, or if you're managing applications and you're an SRE, what you're probably doing is mainly day two events. And that's updating all the applications, updating containers on a high frequency basis to get your changes out the door. So I believe that the folks at Weaveworks who really brought us GitOps started thinking about how do we scale day two events across dozens of clusters? How many operators do we need to do that? And I think what they realized is they just needed one per cluster. Now, in your IAC, you can define your environment to include a GitOps operator when you go and spin up a cluster, which means that every single cluster has their own GitOps operator, which allows GitOps to scale across literally thousands of clusters, because we don't have one sort of agent or operator living outside of the cluster and trying to update multiple ones. Instead, it lives inside the cluster and does a fabulous job of managing our application deployments. Now, it looks very much like infrastructure as code, except for that one small change. It also includes a Docker registry. So what happens is a developer is going to create a deployment file. They're going to check that deployment file into a Git repository, and that Git repository then is going to be watched by the GitOps operator that says if something has changed, like the container tag, then we need to go get a new container and bring it into the cluster. And that is a pretty simple way of describing what GitOps does. Now, it does it through a pull request with potentially a merge and a commit. So it uses Git kind of logic in order to get it moved to a state that the GitOps operator can then read it. And this becomes a very hermetic solution. It is immutable, and that is probably one of the biggest reasons why you would do this. And as Victor Farsik said in a recent call that I did with him, one of the most important things you can do with GitOps is make sure that nobody is touching manually those environments. So take out, delete all of the access to those environments and only let the GitOps operator do the work. This is the best way to keep things as hermetic as possible. So what happens is, how we make that hermetic is a developer makes an update to their code and commits the changes to Git. A new container image is created and registered, hopefully across the pipeline, and that creates a new container tag. This tag is unique to that specific container image. So then the developer updates that deployment YAML file with a new tag and any required key value pairs, and then commits it back to Git in that specific environment repository. So you'll usually have a code repository and then a GitOps repository, what they like to refer to as an environment repository, and that's where you'll check in your deployment file, and that's what the GitOps operator looks for. So the GitOps operator then sees that new commit and updates the cluster with the new container. And that's pretty brilliant, in my opinion. This solution is completely immutable, and it really gets rid of all that manual tweaking. So what's important to understand about this process is that it creates a level of governance through the versioning. So while most development teams have always been required to track their changes, not always operations has been required to do the same thing. They've not always been required to check in their code. And that's probably because they're not branching and merging their code between multiple operations individuals who are sitting there updating these production environments. They're doing that all on their own. And development teams have learned the benefit of a source repository. And I'm not saying the operation teams haven't, they just haven't made it a habit. So like infrastructure as code, GitOps versions all the definitions, so you can see the changes over time. You can also see who did the pull request. You can see who did the merge if one was required, and of course you can see who did the commit. So it's baking in governance and audit into the process. Little secret here, GitOps can also update infrastructure. So let's say your application needed new parameters for that infrastructure. You technically could use it for infrastructure because it's working just like infrastructure as code, except for the fact that the day one, the spinning up of the environment, and the day in, the bringing down of the environment, you need an infrastructure as code tool like a Terraform in order to do that. So when we first started doing GitOps, it really was perfect for containerized applications. And what I mean by containerized application is taking a monolithic software, a traditional binary kind of based software, and pushing it into a container, and then using GitOps to manage the deployments of that container. Everything that the software needed was in that container, and you had one YAML file that described the state of what you wanted for that deployment of that container. And there were big benefits. Without a huge change in our culture, everybody pretty much knows how to use Git. The operations teams know how to use Git. The developers understand how to view things in Git. We were able to create an airtight deployment process, one that had the potential to be repeatable between development, testing, and production. Something that I complain about all the time, that we as a DevOps community struggle with creating that repeatability. GitOps has a very strong chance of making that happen. Now, I'm not saying that more traditional application release automation tools can't do that. But what I'm saying is that this GitOps model fits more into the culture of how we're used to doing things, which makes it easier to adopt across all teams. And with GitOps, we have a high level of confidence of what we store in Git is actually running in our cluster. It's a way to be able to see some basic things about, let me look at the environment for prod, let me look at the deployment file that's in there, and I'm going to be able to tell what's in the cluster. I don't have to look at the cluster itself, so I don't have to have access to the cluster. All I have to have access is to the Git environment. So that's where that governance becomes important, and even if you're doing support, it becomes important. So in essence, what we accomplished in infrastructure as code, and now GitOps is manual tweaking. And while manual tweaking has always saved us in some cases, it can be a source of pain that we need to stop doing. Now, I just spent the last 15 minutes telling you why GitOps is great. So we began our journey with GitOps with that containerized application. But let's think about it in a truly cloud-native environment where we're starting to use microservices, and deploying small functions per container is the way we're building out our new cloud-native architecture. It complicates a lot of things. Microservice complicates our existing continuous delivery pipeline. It also complicates GitOps. It actually complicates everything we're doing. So to say this is a con of GitOps is hardly fair, but was something that we should be thinking about. And I'm going to walk through why it complicates things. So if let's just think about GitOps and how GitOps needs to scale across the pipeline, and think about what that means when we have lots of microservices. So typically in a GitOps model, you're going to probably have a branch per state in your repository and in your pipeline. So when you have an update to dev, you're going to have a deployment file that's for dev. It may have different key value pairs. It may have different configurations for the development environment, and it may have a different container it's referring to. So the tag is different. That's going to be the case for test, and it's going to be the case for prod. So the tag and prod, test, and dev are probably going to be different for the most part. And very likely what they call the config maps or the key value pairs are also going to be different. So you're going to have 3 files for your, historically, which was one big container, an application in a container. You just had to deal with 3 of these. But that's sort of how we have to start thinking about what this is going to look like for microservices, because microservices are independently deployed. So they're going to have their own deployment file, and they're going to have their own dev, test, and prod environments that we're going to have to manage. So let's just take this quick image here. We have a one giant cluster that has a candy store and a hipster store in it, and they share cart, shipping, and payment services. These are microservices that they share. What you see here is that the GitOps operator is going to be looking at the environment repository for the front end for the hipster store and the candy store. And it's also going to be monitoring the cart service, the shipping, and the payment, because these are all independently deployed microservices potentially running in their own namespaces, for example. So instead of having one application deployment file, we have 1, 2, 3, 4, 5 of them for our cluster. Now this is just for this cluster. So now let's add dev, test, and prod. So now we have 15 of them. Now the truth is nobody ever just has one cluster for dev, test, and prod. We have one customer that says they have 17 different test clusters, and they're using tons and tons of microservices. So how do we start using GitOps to manage so many different pieces and make sure that we're not creating more work than is needed, because we're having to do merges and we're having to track all of these different files? Now, certainly you're going to have potentially one individual to manage each one when it comes to development, but then maybe production, you have one person who's running your production environment, and they're having to deal with all of them. Or you might have several people in production. But the point is, we have a lot of YAML files to manage in a microservices world. We could have hundreds of them, and creating hundreds of pull requests and hundreds of commits. And in my humble opinion, it's just not reasonable to expect developers to manage this number of files via manual PRs. So in the same way that we moved away from imperative to declarative, we have to move away from humans doing some of the human side of GitOps, which is creating updating the YAML file, creating the pull request, managing and merge, and managing the commits, because it could be onerous. And it's in this area that we need to have the most discussion about GitOps and how we can bring GitOps into the family of continuous delivery and automation. Because if you're doing microservice, this is essentially what is going to be needed to make this really work and work well. So, this is an evolving space. We have seen changes because of cloud native. Many things have changed. We have seen a change in how we're thinking about applications are constructed. We're thinking about breaking apart applications into smaller functions. We often refer to it as decomposing applications. And microservices are built around what's called bounded context, so that you only have a microservice doing one small function. And in a proper microservice environment, you're going to have a lot of those microservices, and they should be shared. They shouldn't be just written for one application team. They should be written bounded so that multiple teams can use the same microservice. Let's think of it, a login routine for a bank or an insurance company. How many do you need? Probably just one. And that way we can make sure that one is super secure and performing all of the functions that we need in it. If you haven't read any of Tyler Jewell's articles, I highly recommend you do. He does an amazing job of research in these areas. And he, in his article, Foretelling New Approaches to DevOps, he predicted two trends. One was the emergence of the service catalog, and the other is the convergence of continuous delivery, GitOps, and what he calls experimentation vendors. We do need to converge GitOps and continuous delivery. That will be our roadmap to happiness and success, because GitOps does have some real benefits. It is easy to adopt. It's easy for developers to embrace. It's easy to make it repeatable between dev, test, and prod. And as we move into a microservices architecture, I believe GitOps will be a much easier way to manage things than more traditional release automation tools that have been supporting traditional monolithic applications. So while GitOps is useful today, it's going to be more useful in the future if we can sort out a way to really automate the steps of the GitOps process, the updating of the YAML file with the tag, the automation of the pull request, the automation of the merge if one is needed. Let's hope we don't have too many merges in that. And potentially connecting commit to policies or to the CD pipeline when we want to do an approval. That's the kind of discussion that we need to be having in the GitOps world. And I hope that you can join us in that conversation. And if you have thoughts, please put them in the chat so we can really chat about it and come up with some interesting ways to solve this problem. So catalogs are on the move. There are two catalogs now at the Linux Foundation. One is Ortelius, which I indicated I was the community director for the Ortelius project. And there's Backstage. Both of these are incubating at the Linux Foundation, one through the CNCF and one through the CD Foundation. You'll probably start hearing more about these kinds of projects. You'll probably still hear more about catalogs in general. Microservice catalogs are a way to centralize all of the information about microservices. Let's think of let's take an easy use case. Let's say you're a support, you're working on the support team and you get a call from a user that says, hey, the candy store is not working. I can't get my, it won't accept my shipping address. Well, then you call the application team, the candy store team, and you say, hey, your shipping is not working. And they say, well, we haven't changed anything. The microservice changed, but the application team didn't know about it. So how in the world does a support person really know who to call? A microservice catalog is going to show relationships. It's going to show you ownership information. So the application, the support team could look at the application, see what changed, what was different between yesterday and today, what could have happened. And they're going to be able to see what the difference is and then look at that microservice, that shipping service that just got pushed out, and know who to call. That's one simple use case for a microservice catalog. There's plenty of others, including who uses I'm the microservice developer. Who uses my microservice? I want to know that. I need to know who to call because I'm making a big change in it. How do we track that? And if you're a application team, how do you know a microservice exists? How do you know you don't have to write a new login routine? This is the focus of these catalogs. And what I believe is the catalogs will start hoarding that information that can then be pushed off to auto-generate those YAML files for GitOps, which will be a huge, huge step. And then, of course, automate the pull request. So they generate the new YAML file and manage the key value pairs. So inside that catalog, you're going to be able to see what the key value pairs are for dev, test, and prod, for example. And that gets generated at the point in time that a new YAML file is needed because a deployment is requested for a particular microservice. So when we think about GitOps, we can start thinking about not pushing a deployment ourselves, moving a jar file out to a particular location or a new container. What we have to think about when we think about GitOps is deployments now are updating a YAML, a declarative definition file, and checking it in to your Git repository or whatever version control repository you're using. That is the new way of doing deployments, and that is what GitOps is all about. And that's why I say it is operations by pull request. Thank you. Thank you so much for being here. I so much appreciate it. Reach out to me. I'm at Twitter at Tracy Reagan, or again, my LinkedIn address is Tracy-Reagan-OMS. And as the slide says, thanks for being here, and now let's get to work. And I hope you can become part of this conversation and part of helping to solve this problem. And a shameless plug for Atilius: if you're interested in becoming part of the solution and you'd like to contribute to an open source project that's focused on this, please consider joining us, and you can go to ortelius.io, and that is spelled O-R-T-E-L-I-U-S. Thank you.